Hi everyone and welcome to part 2 of topic 3, the water. We're going to be going into groundwater in this portion of it, talking about aquifers. And again, as we saw in the first video, this is the largest percentage of liquid freshwater on Earth, so it is a very vital resource. It's also where you got your water today if you turn on the water in your house. So groundwater stores most fresh liquid water. The groundwater itself is made up of a couple of different zones. If you were to dig into the ground, you wouldn't immediately find pools of water. You aren't going to find it ever in there. You're going to find water stored in pore space, so the space in between individual soil particles. So the first zone, when you dig into the earth, is the zone of aeration, or the unsaturated zone. So this is the shallow layer of soil where there's both air and water. It's not sopping wet. It's not muddy. Once you move further down, you'll get into the zone of saturation where all pore space is filled by water. So any gaps in between sand, silt, clay, mud, rocks is all filled with water. Now, this line, this plane in between the zone of aeration and the groundwater is called the water table. The water table is the top portion of the zone of saturation. You have to hit the water table before you can get water out from a well. Water makes it into groundwater through precipitation, infiltrating, and joining the water table. The plants with precipitation, plants can take up that water, it can evaporate, it can go through a bunch of processes. So of the 100%, so in Florida we get about 52 inches of rain a year, and approximately 6 of that makes it into the groundwater. So groundwater does not get replenished quickly at all. Most water does not infiltrate all the way down, but instead is used up by organic matter near the surface. Aquifers are going to be stores of groundwater under the surface that you can put a well in order to get water. Now this is an artesian aquifer. It's called an artesian aquifer because it's inclined here. You don't have to know that part, but it's just a fun fact. Now, these aquicludes are basically containers. They are layers of rock that water can't move through. So it acts like a natural pipe to keep the water in between the lower and the upper aquiclude. Now, since this is inclined, if you are to put your well below the level of the recharge zone up here, the water is just going to spurt out. You don't have to pump it. It's just going to flow. However, if you put your well over here further, you're going to be too low. So you're going to need to actually pump this well. Back up. Here is our normal water table. Here is our new water table because we've been pumping too much out of it. Now this well is not in our confined aquifer. So this water is under no pressure. Like this one was under pressure. This is under no pressure. So this well has to have a pump on it. So you have to go out and manually pump out your water. Now before we lowered the water table by pumping, this well would have worked because the normal water table should be higher. The zone of aeration is the zone where under normal circumstances, so non-flood circumstances, this area will always be both air and water in the soil pore spaces. This cone of depression is the result of pumping. So think about the last time you had a milkshake or a smoothie or a slushie or an icy. When you were drinking it, when you get near the bottom, you get that moment, right? Where you can't get anything else. You know there's stuff in there, but you have to wiggle the straw around because you've drank everything near the straw. That's a cone of depression. So this well will start to suck up everything near it, and you have to either wait for the water table to kind of come back, or you have to dig your well deeper to accommodate the cone of depression. So the environmentally friendly thing to do is to wait until this can level itself back out and then pump. But what we typically do is we just dig a deeper well. Over here, you have a perched water table. So this rock layer should look a lot like this aquiclude. This is a layer of rock that water can't get through, so it's artificially perched here. Many people in the early days of the pioneers in the Old West They would find these perched water tables and be like, yay, we found water, let's build our city. And a few months later, they drained this perched water table and had to leave. So these perched water tables are small collections of water in the ground, not as expansive or long-lasting as these the full water table that's down here. If you have a water table that intersects with the side of a hill or a cliff, you can have springs, which will be small little creeks or rivers, and those can flow down here into a stream. Streams are fed by the groundwater. If this well were to lower this groundwater below the stream would dry up. So these are connected together. So aquifers hold groundwater and are only replenished when water enters through a recharge zone. So this confined aquifer is only recharged here in this small space. This portion of the water table, that's going to be recharged anytime water infiltrates through the ground. Here we have, these are our local aquifers. So these are our two major ones that we see, courtesy of the South Florida Water Management District. So the Biscayne Aquifer is our most commonly used. We use the Biscayne Aquifer. That's where your water in your home comes from. It is the surficial aquifer with the greatest depth being about 250 feet. So it's pretty close to the surface and it's pretty deep. It was recharged from your rainfall, so basically whenever the rain comes in, when you see the canals, where that water level is, that's about where the water table is. They are related. The surface water and the groundwater level, they are related. Now underneath the Biscayne Aquifer is a confining unit, which is the same thing as this aquiclude from back here. A confining unit is a rock that water doesn't go through. Underneath that is the Floridan Aquifer. So the water from Biscayne Aquifer and the Floridan Aquifer, they don't mix. They don't interact. The Floridan Aquifer is actually going to be mostly brackish to salty water. So that's going to be coming in from the ocean around us. So we would have to purify this. We would have to desalinize. So that's get rid of the salt from in this aquifer before we can use it. Now, up in northern Florida, the Floridan Aquifer is actually near to the surface. The Biscayne Aquifer doesn't exist everywhere. The Floridan Aquifer is more prevalent in the north, and that's where they will pump their water, because further north, it's not salty anymore. So they can vary over space. Again, the Florida aquifers, the Biscayne aquifers, the primary groundwater use for us in South Florida, it's what we call an unconfined aquifer. The entire upper portion is exposed. So what would happen if you had an oil spill here? It's going to get right into the water. Now, because our Floridan aquifer is brackish or salty, we actually inject some of our excess stormwater. So after hurricanes, after big rainy seasons, we will push fresh water into the Floridan to kind of help push that salt water out so it gets a little fresher down here. We're trying to rehabilitate the Floridan aquifer down here. Again, the Floridan aquifer is the primary groundwater for North and Central Florida. It is called a confined aquifer because of this layer of shale in between the Biscayne and the Floridan. There are many dangers to aquifers, including contamination from the surface, but down here one of our biggest concerns is saltwater encroachment. When you remove water from an aquifer, something has to fill that space. There needs to be an equilibrium. You can't remove a liquid and not have that pore space refill. Down here, the closest available material to refill that space is salt water. So if you remove water from here, salt water is going to come in. And we are constantly removing water from there because we're constantly drinking water, showering, washing our clothes, washing our dishes. We're always using our water. So as we remove from this fresh water, the salt water can encroach. And it is a very big problem because, again, we can't drink salt water. Also, if salt water gets into the soil, it makes it so it's no longer fertile and can't grow anything. It is far easier to pollute groundwater than it is to clean it up, which is how it is with most things in life. It's easier to make a mess than clean it up, right? So contamination is a very big problem because it takes a very long time to clean up. 40% of the water used in the United States is groundwater, and cleaning groundwater is very hard. Demand is outpacing recharge. So we are pulling out, so this is a made up number, but just to show you kind of the scale we're at. If we pull out 100 gallons of water a day, we're putting in maybe 1. So the amount we're pulling out is far, far, far greater than the amount we're putting in. We're polluting it constantly through industrial, agricultural, and domestic contaminants. In a lot of places, when they flush their toilet, it doesn't go into the wastewater system that goes to the municipal wastewater treatment plant. It goes into a septic tank or a cistern, which are underground storage units for our waste products. Those things leak, and then all of the contaminants from your wastewater goes into the groundwater. Think about all of the animals there are outside. Think about all the farms there are with livestock outside. All of their waste goes somewhere. All of the runoff from farms, from fertilizers, insecticides, pesticides, and herbicides, that's all going into the water, disposing of waste. Think about dumps. Think about your trash, what you throw out. Water will fall on the waste disposal, and the water will percolate through the waste into the ground to get to the water table, and it will contaminate the water table. So it is a very big problem that we have to face with contamination here. Agriculture uses 70% of the water we consume. It is the #1 user of water. We withdraw more than we consume. 2025, that's obviously a projection. But we're withdrawing, we're wasting water. We're wasting a lot of water. We're wasting even more in the household between withdrawal and consumption. We're wasting a ton of water in our house. The industry is actually a smaller portion for what they withdraw, and their waste is less than between the waste and consumption of a household. So it's very important to be aware of when you're pulling out water and where it's going, because it's finite. So, one last thing to show you on this little mini lecture. In the United States, these are areas where our groundwater is most vulnerable, kind of vulnerable, and pretty okay. So, over here in North Carolina, this is urban areas. These are where you have population centers. Over here, this is Cincinnati, Ohio. Over here, that's Illinois. That's Chicago, Illinois, Gary, Indiana, and a bunch of suburbs. Over here in Wisconsin, in the upper peninsula of Michigan. The very bottom of Alabama. Louisiana, going up through Arkansas and Mississippi. The coast of Texas. This area is where the Dust Bowl took place in the 1930s, which led to a lot of people starving to death. It's under extreme pressure today. We're draining the aquifer. This is an area where we're growing a lot of crops, and we have a lot of livestock in this area, and they're using the water too fast. This is straight up Las Vegas right here. Straight up. Over here in Arizona, we've got lots of problems. Down here, I believe this is Los Angeles, but my California geography is not that great. I could be wrong. But this is one of the valleys, the San Joaquin Valley, plus then some more, where we have a lot of water being lost. We have overdrafts that are of concern in this entire region. We are in an area of concern. So luckily for us, we're not in a high concern yet, but it's very likely that with the next update for this map, we will be. So it's something to think about. It's something to think about the next time you use water, the next time you take a shower or a bath. Think about how much water you're using. So with that one, we will end with groundwater, and next time we will discuss pollutants.